Hi and welcome. I hope everyone is okay. As you remember, in the last lesson, we have been talking about the interquartile range in the ungrouped data. But in this lesson, we will pass the talk about pass to talk about interquartile range in the group data, and then we will pass the other topic. It's named box and whiskey diagram. Okay, now we can start. In the group data, how can we find interquartile range? We can use a cumulative frequency graph to estimate values in any position in a set of data. This includes the lower quartile, the upper quartile, and any chosen percentile. For example, when they give us a data set, we will find the lower quartile n over fourth value, or 1 over fourth multiply the sum of the frequency. And for finding the median, or Q2, n over 2th value, or 1 over 2 multiply the sum of frequency. For the upper value, or quartile, the other name, Q3, 3 over fourth value, or 3 over 4 multiply the sum of frequency. The nth percentile is the value that n percentage of the way through of a set of data, Q1, Q2, and Q3, or 25th percentiles, 50th percentiles, or to 75th percentiles, respectively. In an ordered data set, which, say, for example, we have 320 values. In the 320 values, if we want to Q1, we should make 320 multiply 25%, and we should find the 18th value. 80th value. And if we want to find the median, or Q2, we should find 320 multiply 50%. We should find 160th value. 160th value. And if we want to upper quartile, or Q3, 320 multiply 75%, we should find 240th value. Okay. And for example, they want us to find 90th percentile value. So we should find 320 multiply 90%. So we should find 288th value. If they want us the range of the middle 80% of data set is the difference between if the data set range of the middle 80% data set, we should find, for example, we have we have a data set. This data set is 0 and between 100, and the middle of the value 50, but they want us the range of the middle 80%, the range of the middle 80% for 50 multiply 80%. So it means 40, and we should find 50 minus 40, 10th value, and 50 plus 40, 9th value. So if we find the 9th value and 10th value range, so we can find 80%, the range of the 80 per middle of the range of the 80%, ninth value minus 10th value. Okay, for example, they want us the range of the middle 60% of a data set. If they want us the range of the 60% data set, we should find for example 0 and 100, the middle of the value 50 value. So 50 multiply 60% and becomes 30, and we should find 50 plus 30, and 50 minus 30, and between 80th value minus 20th value give us the range of 60% middle all data set. Okay, if they want us 80%, the range of the 80% of middle of the data set, we should make this process. If they want us 60%, the range of the 60% middle of data set, we should make this process. And then we have a question about interquartile range in the ungrouped in the group data. For example, the following graph illustrates the times in minutes taken by 500 people to complete a task. Use the graph to find and estimate all the greatest possible range. Okay, now we have a cumulative graph, and the cumulative graph related to 500 people, and they want us the greatest possible range. If you notice on the graph, the small data or smallest data means this point. So this range 1 2 3 4 5 6 7 8 9 10 10 gain. So 5 divided by 10, it means 0.5. It means each square equals to 0.5. So 1 2 3 4, and the smallest value is 4 multiply 0.5, it means 2. Okay, now the biggest value, the biggest value is 500 people. 500 people's 500 people's time is this it means 30. So the biggest value is 30 and the largest range is 30 minus 2, 28. Okay, now the other question, the interquartile range. The interquartile range, we should find Q3 and Q1. For finding Q3, we have 500 people multiply 75%, so it means 375 people. And for Q1, 500 multiply 25%, so 225th person. And 125th person. 125th person, it means this 125th person time is Q1, and please remember each square means 0.5, so it means 1 2 3 4 5 6 6 multiply 0.5 3, 5 plus 3 8, and 300 75th person. 375th person means in the graph this situation, and if 50 before 15 1 square, so 15 minus 0.5, it means 14.5, and we can find in the interquartile range Q3 14.5, Q1 8, and interquartile range is Q3 minus Q3 minus Q1, 14.5 minus 8, and 6.5. The 95th percentile. The 95th percentile, we should find 500 multiply 95%, and it means 475th person, and 475th person means on the graph 475th person time is this situation, and it give us excuse me, it give us 25 25 before 1 and 2 square. Each square means 0.5, 2 square means 1, and 25 minus 1 becomes 24 minutes. Okay, now The other topic for the other topic is box and whisker diagrams. A box and whisker diagram or box plot is a graphical representation of data showing some of its key features. The features are its smallest and largest value, lower and upper quartile, and its means. For example, in the box and whisker diagram, this point is smallest value, this point is largest value, this point is lower quartile, this point is upper quartile, and this point is median or Q2. This part name is box, and the all part is whisker. Okay. And it takes the form shown in the following diagram, which shows some features of a dataset denoted by X. Key features of the data for X represented in the box and whisker diagram are, for example, these situation, and it means Q1 this point, and Q2 this point, and smallest value is this point. The smallest value is 1, the largest value is 14, and upper quartile is 11, median is 6, lower quartile is 4, and the median is 6, range is 14 minus 1, and interquartile range is 11 minus 4, 7. And then the following box and whisker diagram is representation of a dataset denoted by Y, drawn using the same scale as the previous diagram. For example, this diagram for Y, the lowest value is 0, and the biggest value is 15, and the lower quartile is 3, the upper quartile is 12, and the median is 9. This is Q1, this is Q2, and Q3. If we want to find a range, we should 15 minus 0, and if you want to find interquartile range, we should find Q3 minus Q1. It means 9, and our median is 9. Okay. Now the following table shows a measure of central tendency and two measures of variation for each of X and Y, and we can use these to make comparisons. For example, in the dataset X, median 6, in the dataset Y, median 9, and in the dataset Y, mean greater than dataset X mean, because the median of dataset Y bigger than the median of dataset X. So we can say in the dataset Y mean greater than dataset X, and dataset X range 13 and dataset Y 15, interquartile for interquartile dataset X 7 and dataset Y 9. So in the dataset Y range bigger than dataset X range. So dataset Y values variable values. By comparing medians, values X are on average less than values of Y. Okay. By comparing rates and interquartile range, values of Y are more varied than values of X. Okay, we had set these expressions. We can assess the skewness of a set of data using the quartiles in a box and whisker diagram. For example, please remember that X box and whisker. X and box X the dataset X box and whisker, Q1 4 and Q3 11, Q2 6, and this range bigger than this range. So Q3 minus Q2 greater than Q2 minus Q1. So it shows us the graph, our graph like this situation. For example, imagine if I image that the graph this range greater than this range, so it means, for example, like this. Please remember that we had set for this graph positively skewed because the mode greater than mean, and mean greater than median. So this graph, longer tail of the curve drawn over a bar chart would be to the side of the larger values, but this range bigger, so longer tail here at the right. Okay, now for example, for the dataset Y, Q1 3 median is 9 and Q3 12, and please notice that this range Q2 minus Q1, this range Q3 minus Q2, and the first range Q2 minus Q1 greater than Q3 minus Q2. So these for the Y dataset, we can say the curve is negatively skewed. If I image that this data set for this data set curve is like this. So this is mode and median and mean. Okay, and so this is negatively skewed because the longer tail of the curve would be to the side of the smaller values. All values is here, smaller values is range, largely range, but in these box and whisker diagrams, some values become comes here. Okay. Now, for example, if we make some practice. For example, this is the box and whisker diagram. This is the box and whisker diagram. And when you look at the okay. Okay. Now, please. Okay. Now we have two box and whisker diagram, and in any question, if you see the mean like this, median, and if you see the median like this. For example, this point is Q1, this point is Q2, and this point is Q3, this point Q1, this point Q2, and this point is Q3. So in the these box and whisker diagram, Q3 minus Q2 greater than Q2 minus Q1. In this box and whisker diagram, Q2 minus Q1 greater than Q3 minus Q2. So you should think about the curve. This curve, like these, positively skewed, because large range, large value is here. So your mode is here, and your mean greater than mode and median. And for the second box and whisker diagram, these range large, so the longer tail is for the smallest value. So your mean is smaller than your mean is smaller than median and mode. So this area is large. You can say positively skewed curve. This area is large. You can say negatively skewed for curve. Okay, and a reasonably symmetrical set of data would have Q3 minus Q2 approximately equal Q2 minus Q1. If Q3 minus Q2 approximately equals to Q2 minus Q1, you can say the curve is symmetrical data, symmetrical curve. So this is like this symmetrical curve. Okay, if Q3 minus Q2 equals to Q2 minus Q1. Okay, we have some example about whisker and box diagram. The following stem and leaf diagram shows the marks out of 50 obtained by 15 students in a science test. Okay, we have 15 data, and I want to write the data from smallest to biggest. So 9 and 14 and 25, 28, 40 and 41 and 41 again, 47, 49, 39, excuse me, 39, 43, 45, 46, 48, 50 and 50. Find the range and interquartile range of the marks. Our range is, the biggest data minus the smallest data, 41. For the quartile, we have 15 data, so 15 plus 1 over 2, eighth data is median, and 1 2 3 4 5 6 7 8, this is median, and we have 7 data here, and we have other 7 data here. So in these 7 data, middle of the 7 data, 28, this is lower quartile, and the upper 7 data, middle of the upper 7 data, 49, 46, this is upper quartile, and interquartile range, Q3 minus Q1, and 46 minus 28, it means 18. Okay, illustrate the data in box and whisker diagram on graph paper and include a scale. Okay, now we will draw whisker and box diagram, box and whisker, doesn't matter, and this is smallest data, 9, this is biggest data, 50, and Q3 46, Q1 28, and our median is 37. 37 is the middle of the 28 plus 28 and 46, because please notice that 37 means 28 plus 46 over 2 means 37. So 37 or Q2, the middle of the exactly certain middle of the Q1 and Q3. So our curve should be symmetrical curve. Our curve should be symmetrical curve. Okay. And for this data, express Q3 in terms of Q1 and Q2. Okay, now we could find Q2, the middle of the Q1 and Q3. So Q2 equals to Q1 and plus Q3 over 2, and it means Q1 plus Q3, 2 multiply Q2, and Q3 means 2Q2 minus Q1, and we can express Q3 in terms of Q1 and Q2. Q3 means 2 multiply Q2 minus Q1. Okay, for now our lesson is finished. For today, have a good lesson and have a good day.